Hi everyone, I'm Shareen, and on behalf of my co-authors, I'm presenting our work titled Learning Through Exploration: How Children, Adults, and Older Adults Interact with a New Feature-Rich Application. The problem space that we're looking at is modern feature-rich applications such as Microsoft OneNote or Photoshop that offer hundreds of features organized under different menus. Learning these applications can be a challenging process for newcomers. Not only do they have to determine which feature might be relevant, they also have to locate it on the interface and then be able to use it correctly. Today, these applications are not only being used by adults, but also by children and older adults in different contexts. And often, the learnability problem is particularly acute for newcomers that include diverse age groups with different past experiences with technology. Despite the availability of help resources, prior work has shown that users often tend to learn a new application through self-directed exploration or trial and error. Previous work on children's use of a simple gaming interface has shown that they can be eager to try out different actions just to get ahead in the game, whereas older adults can be fearful to try out new options and make mistakes, for example, when learning to use a smartphone. However, little is known about the interface exploration styles when learning to use a feature-rich application for the first time, and no study has looked at all three age groups simultaneously. So we wondered that if we give newcomers from different age groups the same feature-rich application, how would they explore it? Would they approach the interface differently? Or what struggles would they face? Understanding the age-related differences in exploration styles could help designers make more inclusive design choices, improve the software onboarding process for newcomers, and prevent software abandonment. So we conducted an in-lab structured observational study where our goal was to observe how the participants interacted with a feature-rich application. We had 3 age groups taking part in the study: 10 children, 10 adults, and 10 older adults. Our choice of application for the study was Microsoft OneNote, as it is a relatively newer application being used in work settings as well as by children at school. The central components to our study procedure involved the participants taking part in the structured observation, where we gave them a list of tasks to carry out with OneNote and recorded their eye gaze and laptop screen. After that, the participants talked about their overall experience of using OneNote in a brief semi-structured interview. We gave the participants 2 main tasks to do. We asked them to imagine that they were taking 2 online classes, art and science, for which they were maintaining a digital notebook. Both the art and the science tasks also had some subtasks. The 2 images below show the end result of the art and the science tasks, some of which required the participants to draw a flower and find information about polar bears within OneNote. Our data analysis predominantly involved video coding, where after multiple iterations, we created a codebook with a set of events related to participants' exploration activities. Some of the events included the participants making an off-task selection, which was not useful for the particular subtask that they were doing. A second example is Skimming, where they looked through the menus without selecting a feature, which was captured by their eye gaze. We then used this codebook to tag all of our observational screen recordings with the relevant events, which gave us our coded video files. After that, we continued our data analysis by running statistics on the coded video files and analyzing the interview transcripts to identify recurring themes. We will now look at the key takeaways first and then step into some of the details. We found, among other things, that counter to our expectations, children explored the interface carefully. One thing, though, was that they struggled to locate the right-click menu, perhaps due to a lack of mouse exposure. Whereas the older adults struggled to determine the correct sequence of feature selections and repeated irrelevant selections. The adults performed well relative to the other 2 groups, where OneNote might have been less feature-rich for them. So we will elaborate on some of the results for children and older adults. In terms of the overall performance, if we look at the graph of average task completion times, we see that children were almost as fast as the adults, whereas older adults took twice as long. When we further broke down the total duration into the events from our codebook, we found that the biggest contributors to older adults' longer performance times were the time that they spent skimming the interface and performing off-task actions that were not sufficient to succeed in the task. When it comes to exploration, children and older adults approach the interface differently. Older adults did not sufficiently explore the different menus and only looked where they expected the feature to be. They made a higher number of non-unique selections where they selected the same feature again. Although children performed as well as the adults, the majority of them did not explore the right-click menu, and one of them even explained how he discovered the right-click menu by accident. In addition, some of them did not initially realize that there were more menus besides home. When we further looked at the nature of the non-unique selections made by the older adults, we found that they had these off-task selection cycles where they repeated the same sequence of irrelevant selections. We have a figure here that shows the shortest path for a assigned subtask with the relevant selections in green. One of our older adults, O7, initially deviated from the shortest path and made an off-task selection cycle where he went back and forth between selecting undo and search before finally getting back on the right track. Whereas O4 also made off-task selections but had a longer off-task selection cycles and eventually gave up on the subtask. In addition, older adults particularly struggle to understand the outcome of selecting the undo button. For example, if we select the search notebook button, it opens up a pop-up menu that impacts the interface but does not cause any change to the content of the notebook. However, the majority of our older adults selected the undo button, hoping to undo a selection but accidentally removed content from their notebook instead. Lastly, when faced with a breakdown during exploration, children read the text labels carefully and some of them specifically mentioned the tooltip, whereas older adults carried out trial and error and one of them even mentioned how she was clicking on everything one after the other to see if something fit. This often caused them to get frustrated. Talking about design implications, we saw that older adults had these off-task selection cycles that the interface could detect and offer support. One possibility could be to invoke a heat map of users' recent selection cycles and encourage them to better understand the use of those features by leveraging the tooltip. We also found that older adults spent a lot of time skimming the interface, and children often did not know about right-clicking. So the system could support feature discovery and skimming by appropriately revealing signifiers for hidden menus. For example, there could be a review button that the user could be encouraged to click on during skimming to get a sense of the right-click menus. Finally, to help older adults understand the scope of selecting the undo button, the system could show them their action history and help them distinguish between selections that caused a change to the interface and those that were associated with the content. Then they could undo either of them. We envision these design recommendations to be particularly useful for children and older adults as they would be triggered based on the user's interaction. To summarize, this work has looked at how newcomers from different age groups learn a feature-rich application with an emphasis on interface exploration. We believe that this is an important first step towards characterizing the age-related differences in exploration and accommodating them through design. Thank you.